I had a question the other day about wiring up a motor, a compressor motor actually, and they were talking about a three-phase motor. Now, three-phase motors, you can sometimes wire them up in low voltage and high voltage. Low voltage, well, we only have two different voltages when we're talking about three-phase. Either 2A230 or we're talking about 480 volts. Now, some people say 220, some people say 230. It's basically the same thing. When you're talking about 480, some people say 460, some people say 460, 480. It's basically going to be the same thing. The thing to remember is that you're going to have what they call high voltage and you're going to have low voltage. The 220 or 230, whatever you want to call it, that's going to be the low voltage, three-phase. The high voltage is going to be the 480 volts. Like I said, some people say 460, others say 440, whatever. It's still three-phase, and it's going to be in the 440, 460 range. Okay, three-phase, what does that mean? That means that we're going to have, basically, we're going to have L1, L2, and L3. We're going to have three hot wires coming here, and they're going to be supplying my motor. Now, when the question that I had was specifically about a two-part start winding. Two-part start. What does that mean? Well, just like the name says, it's going to start in two parts. In two parts. To understand that, first let's talk about just three-phase motor. Three-phase motor, you're going to have basically a winding here. You're going to have another winding here and another winding here. Okay, no problem. So to make life easy, let's label this 1, 2, and 3 like this. So we have three windings, and the magnetic field is going to be rotating like this. So as it rotates, well, the rotor that's in there is going to rotate like this. And as the rotating magnetic field, that makes the rotor rotate. So we have to have these, and I don't want to get into too much of this, but the engineer that designed this, actually it was Nikola Tesla, who said a long time ago that they need to be 120 degrees off each other. So from here to here, it would be 120 degrees. From here to here, 120. From here to here, 120. 120, 120, and 120, when you add them up, that's 360. 360, if we start here, go all the way around, 360 degrees. Okay, never mind all of that technical stuff. Let's look at the actual wiring. So we have the three windings here. These are going to come off of, let's say, here, and they're going to be going to a contactor. Okay, here's your contactor. This contactor on this side is going to say T1. T1 for terminal 1. This one is going to be L1 because this is coming off of here like this. L1 feeds this here. Okay. Then we have the other contactor here. This would be L2. And yes, of course, this would come to here. So this L2 right here, what this is going to do is going to come and it's going to, and this might get a little complicated, but let's say that it's going to come here and go there. Then we have another one because, again, this is three-phase. So we have to have a three-pole contactor. So this is going to be L3, and this is going to be T3. This is going to be T2 right there. T, because this is the terminal. This is where it's going to. It's going to the motor. You notice that 3 is going to 3, 2 is going to 2, 1 is going to 1. Okay. This one here is going to have to come up, and we're going to feed all three of these. So now, what happens is when we have, let's say, the 24 volts, it's coming from the transformer. We have 24 volts going to the transformer. It's going to go to, let's say, the thermostat. The thermostat says we need cooling. So then it's going to send 24 volts to the coil for this contactor right here. So this is going to be my 24 volt power supply coming here. This, of course, is going to come back here and is going to go right on back over there, because remember, this is the load. Thermostat calls, sends power to here, energizes this coil, all of these pull in, we get power to this, the compressor starts up. Okay, so this is your basic, simple compressor. Now, what happens is we said that we had the two-part start. So we have these right here, and then we're going to have another set of windings like this. We're going to have a set of windings. So now, this will have to start up, and then the second part will be this one. Now, I don't know if you have ever paid attention to it, but when you are hooking up a compressor, typically what happens is you have 1, 2, 3, 4, 5, 6, 7, 8, 9 connections on there. 9 connections. Now, some of the manufacturers, what they do is they will have this one as 1, 2, 3. 1, 2, 3. They'll do them like this. Just like here, 1, 2, and 3. So these 3 are this one. This one is that one. This one is this one. And this one here is this one here. Okay. Then, on a 3-phase motor that can be wired for low voltage and high voltage, you're going to have the 2 sets of windings like this. And you're actually going to have 9 connections. What some of the manufacturers do is they will have 1, 2, 3. Then this one is going to be 4, 5, and 6. This one will be 7. This will be 8. This will be 9. Like this. In other words, this one here will be 7, 8, and 9 like that. So that would be this one is this one, 8 is this one, 9 is this one. What about 4, 5, and 6? Well, this will be 4, 5, and 6. What did we do here? We connected all of these together. So what the manufacturer will do is they're going to give you some pieces of copper. You're going to have some little plates in there, and you're going to have to figure out how to do this. It's really not that difficult. If we think about it, we said 1 goes to 1, 2 goes to 2, 3 goes to 3. And that's here. We're going to hook up 4, 5, and 6 together. So we're going to have one of those copper pieces, and we're going to put it right there. Once we put it right there, then we just hooked all of these together. No problem. So now, if you notice, number 1 is on top, 7 is on top. 2 is on the right side, bottom right side. 8 is on the bottom right side. 9 is on the bottom left side. 3 is on the bottom left side. So what do we have to do? We have to hook this up just like we did this one. Exactly like we did this one. Now, before we get into that, let me just say that if we were hooking this up for high voltage, we would hook these 2 up together, these 2 up together, and these 2 up together. So that now, once you send power to this, sending it here and here, here and here, here and here. Let me do this and maybe this will make more sense. So now, we said that we have this set of windings with a contactor. We're going to need this set of windings with another contactor. So what we're going to do is we're going to put here another contactor like this. So now, 3-phase, 3-pole contactor. This again will be L1, L2, L3. This would be T1, T2, and T3. First of all, let me explain. This is just a switch. That's all it is. In other words, it makes contact and it breaks contact. If power is going to come in here, it's going to go out this way. Could you make it so that power comes in here and goes out this way? Yes, you can. But we always hook up power coming in to L1, always power going out to T1, because that way when we look at it, we see that the L's are supposed to be the line side. That's the hot side. The T's are the terminal. That's the one that we're breaking. Keep that in mind so you hook these up properly. If you reverse the wires, so you feed it here and then from here it goes out here, it's not going to hurt anything. But when someone looks at it, they may say, oh, power is down because you hooked it up to T1 and they're not getting anything because this is disconnected. Someone could get hurt. So make sure you always do this. Okay, there's a lot more to talk about contactors, but let me just stick to this two-part start. So now, just like we did here, T1 goes to the top one here. So same with this, T1 goes to the top one here like this. Then we did T2, went to here. Okay, T2, we're going to run this to this one here. So they're both going to the bottom right like this. Then T3 is going to come out like this, and we hook it up right there. Now what we're going to do is we're going to take this. This may get a little confusing, and I hope it does not, but we're going to take L3. We're going to start off with L3, and we're going to hook it up straight up here to L3 like this. So when power comes in here, it's going to come here, and it's going to feed the ones on the lower left. L2, what are we going to do? We're going to come here, and we're going to feed it right off of L2 like this. Okay, and then we're going to have to come off of here to L1, and we're going to come up here and hook it up there. Now what's going to happen here? When all of this side is hot, everything on that side is hot because it's coming in from the disconnect, the disconnect that we have. So now all of this is hot. This is going to be dead until the thermostat calls for it. It's going to energize this, and that's going to pull this in, energize that. If we were to hook up another, because this one has to have right here on this side, this one has to have another coil. So this is going to be your contactor coil here, and this is going to be my contactor coil here. This one is for this one is for that. Remember, the outlet of this is going to go back where? To the transformer. It's going to go to the transformer. So, to the transformer. Okay, but where is this coming from? This power it can be coming from the 24 volts here from the thermostat. If we were to hook it up to here, both of these would energize at the same time. Both of these would start at the exact same time, and because of that, my amperage would be high. A minute ago, I was telling you that we could hook up these two together because we're going to have other brass plates. Brass or copper plates that they use, you can hook it up here, here, and here, so that now everything starts up at one time. But we don't want to do that. We want to start this one up and then this one. Now on large contactors like this, on the side of it, you have a small space so you have small area so you can hook up what they call an auxiliary contactor. An auxiliary contactor like this. Now, this usually just goes screwed right onto the side of the contactor. And as soon as power comes in, closes these, this is going to close at the exact same time as these. Now, typically what we do is we take the 24 volts. Remember, this is going to be the common for the transformer. This is going to be the common for the transformer. This is the hot here, and this is the hot from the thermostat. So what we do is we break it off of here, and we run this straight down like this to here. We run it straight down to here. When it calls for cooling, both of these will come on at the exact same time. The amperage will be high, and we don't want to do that. So what we do is we do not feed it like this. This is not how we do it, because again, when we do this, it will work. That's not a problem, but your starting amperage will be high. And we do a two-part start to keep that amperage down. So what are we going to do? Well, let me show you. Okay, so now, when power comes in here, and it goes to this coil, is going to energize this. We're going to break it off, and we're going to come back down like this, and then we're going to take this over like this, and we're going to go to the auxiliary contact. These auxiliary contacts will close when this closes. As soon as these close, what's going to happen is power is going to leave here, and it's going to come back like this. And now we're going to feed this. So remember, what's happening here? The system calls for cooling. When it calls for cooling, we get power coming from the thermostat here. It energizes this. As soon as this energizes, these four contacts close at the same time. These down here on the bottom, these are your auxiliary contacts. They're going to be normally open. So when you put power to this, these will close. Once they close, it sends power out, and it feeds this other coil, closing these. So you're going to hear this boom, boom, like that. Once you hear that, that little time delay, that's enough to get this going, and then this one will start, add a slight delay. Now remember, electricity. How fast does electricity move? Electricity moves at the speed of light. So that small time delay that we're looking at right here, in electrical terms, it's very, very large. It's a big, big time delay. So this is how we basically hook up a two-part start. I know it looks a little confusing, so you may want to watch this video a couple other times. But remember, L1, L2, and L3 feeds L1, L2, and L3, L1, L2, and L3. T1, T2, and T3 feed 1, 2, and 3. T1, 2, and 3 is going to feed 7, 8, and 9. 4, 5, and 6, they go hooked up together like this. One of the things I was telling you before was that we could hook this up like this. So now we only need one contactor. We're going to run L1, L2, and L3. Oh, I'm sorry, T1, T2, and T3 here. That will send power to here, 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 and here, here, and here at the same time. It starts right up in low voltage. It starts right up in low voltage. So that is one way of doing it. What we're doing is we have one, two, three, 4, 5, 6, 7, 8, 9. So what we're going to do is we're going to have a wire. Well, we're going to have these connected together. 4, 5, and 6 connected together like this. We're going to have T1, T2, and 3 going here. So this would be T1. This would be T2. And this would be T3. Then here on this side we have T1 going to 7. So T1 will be going to 7. That's for the red lines right here. Then we have T2 going to 8. And then we have T3 going to 9. So again, on here, you notice that we have basically, you can say, this red circuit here, which is for this set of windings. The yellow or gold one here is for this set of windings. And we're hooking 4, 5, and 6 together right there. This is how you would hook up a two-part start. This is basically how it would look like rather terminal connections like this, and you would jump these 4, 5, and 6 all together like that, so they're joined together. If you're going to use only one contactor and you're going to go straight across the line, that's what it's called, then we can just put those brass pieces here, here, and here, connect those. So basically you're feeding 1 and 7 at the same time, 2 and 8 at the same time, 3 and 9 at the same time. I was saying that these can also be hooked up if you have 9 connections, low voltage and high voltage. I said that If it's high voltage, it's going to be 480 volts. Okay, and so basically what we're going to be doing is, if it is for high voltage, these little brass pieces here, you're not going to put them there. You're going to put them across 7 and 4, 8 and 5, and 9 and 6 like this. Then you would feed L1, L2, and L3, just like you would right here. And now you have this set up for high voltage. And these here would be for your low voltage. Both of these would be for low voltage. You can wire them up either way, straight across the line, or 2-par start. Now there's a lot to talk about on 3-phase motors, and whether you talk about a compressor or a fan motor or whatever, it's all the same. But this is basically how you would wire it. You may have to watch this video a couple of times, and I hope all of this didn't confuse you. I was just trying to help. Again, my name is Julio, Aircon Academy. Please follow me on Facebook and subscribe to my channel on YouTube. If you have any suggestions, let me know and I will see what I can do. That's why I did this, because somebody was asking me about a 2-par start motor. Again, Aircon Academy, and hopefully this helped. Thank you. I'll see you soon.